There are two very important announcements. Haha. Feedback that just will get. So if you got something that's just general con stuff, or you like Ethan so much that you want us to hook you guys up, we can do that. Just let us know, and we'll make it happen for you. All right, we ready now?
Yeah, give me
5 seconds. I can't even pose, as it turns out. So yeah, I'm just gonna hand this to you. All right.
Hello, Shmoocon 2009. My name is Ethan O'Toole, aka Telemonster.
And my name is Matt Davis, also known as Inferix, and we're both with 757 Labs. And we're going to talk to you briefly about a project that we've been working on called OpenVulture. It's a free and open source software / project that we've been kind of confronted with. And the whole idea was, hey, let's take a computer, let's throw it up in the air, hope it flies, and then do really cool, nerdy things. So what kind of things do we want to do? Well, we thought, hey, let's do some wireless sniffing. That would be kind of useful up in the sky. A lot of coverage. Also, we thought, hey, let's throw a camera on there. Let's see what kind of surveying kind of applications we could use this for. So right now, it's a work in progress. And with that said, my goal was primarily to focus on the software side of things. However, Ethan is the hardware guru over here. And what we have today is we're presenting the software, but we're also presenting the information. And you guys can do whatever you do with information.
The original goals of the project were that it's Linux-based and not an embedded microcontroller. We wanted to be able to modify the flight plan while the plane is in action so that if you change your mind as to the destination, you could update it as it's progressing. Wanted it extendable so that it could be used on a whole bunch of different hardware platforms, because as we came up with new ideas as funny things to do with it. We wanted it to be usable during the daytime and the nighttime, because a lot of the other projects use a mode to keep the stabilization of the plane, which is infrared. So it tells the sky from the ground by infrared light. So what happens is when you get over water, the light reflecting back confuses it, as well as when at nighttime it doesn't work because there's not enough infrared light. It is a work in progress, but it's progressing pretty well. And it is pretty much just for fun. There's no commercial side to it or anything. There's currently two projects that are similar. One is Paparazzi and the other one's ArduPilot. However, both are microcontroller based. They're both fixed wing. They do use the infrared sensing, which we're trying to avoid. They have some pretty decent ground control software. And at least the one of them, the ArduPilot embedded board, is very cheap. It's like $25. So even if you don't use it, it's still worth buying one just because it's so low cost. A not so similar project is Autopilot, which has been out there probably the longest. It's for helicopters, and it's on SourceForge. It uses a actual microcontroller to read the I/O from all of the hardware, and what it does is it passes that through to a compact PDA, I guess, which is on board the helicopter. It's definitely not for fixed-wing planes. Those helicopters are really expensive. They're not those small electric ones. Potential vehicles for our project, there's fixed-wing aircraft was the initial goal, and then we started moving towards cars, boats, ships, and submersibles. Although with submersibles, you lose GPS guidance, so there's some new challenges there. The current computing platforms we are developing against is the first one is the Technologic Systems ARM board. It's about $170 embedded board, which is fairly well stocked as far as I/O. It has 5 serial ports, 2 of which are normal RS-232. The remaining 3 are 5-volt logic, and they don't contain all the signal lines, but that's still good enough. It has onboard digital I/O. It has a 10100 Ethernet, 2 USB host ports. One downside is it's stuck on the Linux 2.4 kernel. I don't think they're planning to go ahead, so that drops a lot of support for various USB devices. One really nice thing about it is the input voltage on that board is 5 to 20 volts. It has its own onboard switch mode power supply, so you can pretty much power from any kind of battery, and as the voltage drains, it's not a big deal. However, we kind of moved forward and kind of started looking at the NSLU2, which is a Linksys storage device. They're pretty widely hacked, and more importantly, they're really, really cheap. So they have a 10100 Ethernet port, 2 USB host ports, 200 megahertz, 5-volt DC power. There is one serial port that can be added on once you, it's basically soldering in the pins for the header, and it's 3.3 volts, so it's not the full compliant serial, but it works with a lot of the other embedded boards. A lot of the other PIC microcontroller-based add-ons. It's 2.6 kernel, which is very good. That way you can run a lot of modern USB drivers and pick up a lot of new devices that are developed, and yeah, it's cheap. And on the left is the Technologic board, and on the right is the NSLU2 versus a quarter. One thing, if weight becomes a concern, you can easily strip off all the connectors, replace them with just pin headers, and ditch all the USB connectors and ditch the Ethernet connectors. Currently supported devices by the OpenVulture modules. The first one is a GPS navigation module. It reads your standard NMEA data from pretty much any GPS hardware module out there. Serial's no problem. USB is generally no problem as long as the kernel supports the serial chip. Next device would be the RC Servo output module. What this does is it actually receives commands from the computer and it positions radio control vehicle servos into a fixed position. The original one we were developing against is the Mini SSC2. It's a pretty small board that has its own little microcontroller and receives 3-byte ASCII commands. The first one's a header, the second one is a servo number in a thirds position. It actually drives 8 servos per board. However, recently there's a bunch of others that have cloned their protocol and are offering devices that are much less cost and smaller. So the current one that we kind of adopted now is it's the Paululu, I guess is how they say it, and that's a quarter next to it. Very, very tiny. It has both 5-volt and 12-volt serial support, 8 output for servos. Pretty nice thing. And another thing that has to be mentioned is these boards here, which are identical in function, they're a serial switch. So they're a servo switch. So what it does, it allows you to take the radio from the vehicle, feed it into the switch, and then feed the output from the computer into it. So that way, if for some reason the software messes up, you can use one channel of the radio, and what you do is, by pushing it up over half of the value, it'll switch from the computer back to radio control. So if something's going really, really wrong, you can kind of grab control of the aircraft or ground vehicle. The next module is the IMU module, which is Inertial Measurement Unit. It's a 3-axis gyroscope and 3-axis accelerometer module. The initial one we chose about $360, made by SparkFun Electronics. It has an onboard PIC microcontroller, which samples the analog output to those sensors, and then it passes it over to the computer, and it implements the Kalman filtering for leveling off the data. Serial communications, the downside is it was defective, as far as I can tell. The actual accelerometer had no output ever, and it was past the warranty by the time I noticed this. So it's pretty much, I tried to fix it, and now I just have kind of a stack of parts. It wasn't pretty, and it's all surface mount and very tiny, so repair is pretty much impossible.
I don't think they refunded it.
So now we're moving on to a new one. And this one I actually found randomly on the internet. It's made by Analog Devices. It's the ADIS 16350. It's a 3-axis accelerometer and 3-axis gyroscope with it has its own embedded microcontroller from the company, and it actually talks digital outside of the device, although it's not RS-232. It's more like an embedded microcontroller serial protocol. It's small, it's very compact, it's totally cool. And we just got the development board right before the con here, because it was actually like a month-and-a-half lead time, which they didn't originally say when it was ordered. And unfortunately, there is no Linux support for the development board yet, although I think we might actually write it. That's the actual new sensor, which unfortunately I don't have a picture of the old one. But it's very nice. The only downside is that connector is very tiny. It's pretty much a surface mount pen header that it mates to. And there's the development board there. So that's actually a 8051 microcontroller that Analog Devices provides as part of their kit with a bunch of Windows software to test it out. But it needs to be converted to Linux. The next upcoming module would be the DO module, which is a simple digital input-output. It's needed to run some of the other external equipment. Write bytes to the port, they show up on the pins electronically. Future modules that have always been planned is a linear actuator module, so that it's possible to steer larger objects, such as those electric buggies at Walmart, and a friend of ours' boat, and some other just odd stuff for fun. And I think we're going to follow the EMC CNC control protocol so that it kind of shares the same format and controllers. The other part is a magnetometer module, so that if the GPS fails, you can still get a compass reading. And right now, looking at those boards, they seem to be very expensive, so I might have to make one of those. A brief layout of the actual electronics of it. You have the serial output of the computer comes into the servo controller. There's the switch, and there's the output from the radio, and there's one extra signal line. So it runs the servos that would either steer a car or move the flight surfaces of a plane. An electronic speed controller, which controls the prop of a plane or the motors of a vehicle. If it's a gas-powered plane, you would replace that last electronic speed controller with another servo for throttle. And then on the computing side, you have an embedded computer. It feeds serial. It reads the GPS data via USB or whatever your method. Digital camera, IMU, Wi-Fi if you need it, anything else. As far as communicating with the plane, it's pretty much a network device. So we're actually pushing towards GPRS using T-Mobile because they don't require a contract to get an additional card, because I don't really like having my phone card in the thing. And low cost, you can get the modems really cheap off eBay. They're using a lot of fleet vehicle hardware devices. It is slow, it's not fast. Even the modems I've been getting are non-edge, so they're double slow. And that's actually one of the modems there compared to a quarter. It's actually probably one of the heaviest devices, not because of the case, but just because of the metal on it and the shielding. EVDO, of course, much faster, a little bit more expensive, requires a commitment. Everybody is pretty much familiar with it, Verizon and Sprint. VHF and UHF packet radio, under the ham radio licenses allow for encryption for the purpose of controlling a model. It's pretty much the only exception made for using encryption with a ham license. There's APRS, which is a position reporting system which uses packet radio, which would be useful for finding the plane. And there's a bunch of amateur radio people that have made kits that actually really small embedded boards that they broadcast the location beacon. And of course the FRS radios, which is cheap little Walmart walkie-talkies. There's some kits out there that are about 25 bucks that pass 1,200 baud data down them. But I don't think that's actually legal. So Festival for Speech, if you have sound hardware, would probably meet the laws. Wi-Fi, of course, and fastest, omnidirectional on the plane, directional on the ground, amps up to the legal limit. And analog video, there's a bunch of, I don't know, low-cost Chinese equipment on eBay, but most of it does not stand up to the distances they say. A lot of the quality is really bad on it. So we're trying to hope to stick to the digital. Pretty much obvious applications for UAVs, search and rescue, aerial photography, surveying and reconnaissance, and messing with people. But the aerial photography was kind of a big one, to be able to do very, very high resolution using cheap digital cameras from the air. And I'm going to pass off to Matt for the software.
All right, well, you might be asking, well, why are we doing this? Well, it's just kind of something to hack on, just something to do. And we wanted to provide something back to the free and open source community that you guys can extend and hack upon as well. And Ethan didn't mention it, but it'd be really cool to take one of those carts that people buy stuff in and then just, have it mystically take over and drive down the aisles that we want. Anyway, so we had 4 really major goals that we wanted to do with the software here, or actually goals/results. First of all, we wanted to keep it simple. We didn't want to lock down to one single kind of module. So it's all very module based, and the modules are those little devices that Ethan just talked about. There's like the IMU board or the GPS board. Those are all little modules. And also we wanted to keep it cheap. So we want people to be able to kind of create their own little hacking toy themselves. And with that, we it's free and open source software. It's free as in freedom, but free as in price as well. Also, we didn't want to just stick to just UAVs. That was sort of the base case, but we wanted to be able to actually test this dealie, and it'd probably be nicer to test it on an RC car or something that it's not going to crash and cause possible damage to humans. Also, we're going to go ahead and talk about the library here. And Vulture package really comes in 2 pieces of software. When you download it, you get libvulture, which is kind of like the glue. It's the thing that binds all those modules together. It's a shared library, and basically all it does is it allows userland to talk to your modules. So it's just an easy API that anybody can use to kind of construct their own Vulture application. Okay, and next slide. Okay, and this is the second piece of software that comes with it. It's kind of like it's a good just route following logic piece. And all this, I can't say it's good, but it's route following logic. And it's just using the libvulture, and it just follows a set of waypoints. And it also provides a few little utilities, such as like a socket-based connection, and so you can query for what your platform is actually doing and everything. It's available on SourceForge, and it's also on our 757 Labs website. So you're more than welcome to pull it down, hack away at it, make complaints, comments, whatever have you. Ethan is more knowledgeable on the hardware side of things, where he's going to kind of wrap up the presentation, and he's going to kind of cover what we have right now.
Okay, a friend of ours named Mike Logan is actually an RC hobbyist. He's constructing a couple planes, and he's done a few before that are actually UAV guided, but it's going to be the test bed for our actual software. The planes are actually made of foam, which is a Foamular 150. The nose of the fuselage is EPP foam, which is stronger. Therefore, if you were to crash or do a rough landing, it would survive much better. He's CNC cutting it using a hot wire, which is where you end up with basically two poles at the end of a table and a hot wire stretch between them, and the actual poles move on stepper motors so that a computer can guide it to cut the parts out. Although I think he might actually not even be doing a computer layout, just stepping them by hand. One of the test planes has a 12-foot wingspan with a 6-foot fuselage, and the other one has a 9-foot wingspan. They're running on 8 amp-hour LiPo battery packs, which pretty much give 45 minutes of runtime. One of them could actually, the larger plane could have 2 of those batteries in it, so it would double that runtime. And they move pretty quick. Rimfire motor, 12x8 folding prop, pretty heavy payload. It's actually no deal for it to carry all this computing equipment. We could be sloppy with the connectors and everything. It's really not that big of a concern. There's more stability in a large plane than on a small one, so it should be better for the video operations. And unfortunately, there is no off-the-shelf large foam kit for building UAVs that's really suitable. Most of them are really expensive, really good-looking model planes. And here on the left, you can see kind of the wing components. So there's basically an aluminum seat channel that runs down through them for some rigidity. And he's also using carbon fiber rods so that they can be pulled apart because it's so long it doesn't fit in the vehicle. On the rightmost box is the actual fuselage for the 12-foot plane, and to the left of that is the one for the 6-foot plane. And there he is standing next to the actual assembled wing for the 12-foot wingspan. In the center, it's actually wrapped in Kevlar and Kevlar and carbon fiber. It's like a bag that it goes in, and the other pieces will be as well. They're just not done yet. Unfortunately, the weather's been kind of really cold down there, and I think he's assembling it in the garage, so it doesn't set up properly with the glues. And that's him once again with the wingspan of the larger plane. As far as the legalities go, must stay below 400 feet, which is pretty much a model rule. I think it may have to be in visible range, but not 100% sure. It seems as if the actual commercial people have to adhere to more rules than the hobbyists for some reason, because I guess the laws haven't caught up with what's going on yet. You have to stay away 3 miles away from an airport, obviously. Unfortunately, where we're at, there's quite a few airports, both military and commercial, they're all over the place. So we pretty much have to travel out a little bit to stay away. And of course, you want to be careful. If you have a plane that goes down, bad things are going to happen, depending on who's there. And same thing with cars. You know, the LiPo batteries, even though it's not a gas engine, if you short them out, they can get pretty violent pretty quick, just because there's so much power potential in them. A rough cost, the electronics, running down at about $1,100, not including all the foam for the plane. The most expensive parts are probably the battery pack and the IMU board, and you could probably change the battery out if you didn't need that long of a runtime. You know, if you only need to fly for 10 or 20 minutes, you could use a much cheaper battery. Cool stuff that we hope to explore. Stereo vision from the plane was an early thought. And another one that's kind of been a curiosity is laser range finding. All the sensors that are used in the robotics are about 7,000 to 8,000 on the entry side. But there's all these units that are made for golf course and hunting range finding. So there's kind of been a theory, could you hack one of those to turn it into a range finding scanner for robotics? We have a car test bed that's here. That's actually the reason for the Barbie Jeep. And I actually put it out on Craigslist trying to get Power Wheels to hack on this. I didn't want to buy one new. And scored it for $10. The guy said it would be kind of manly once you peel off the stickers, but it's got pink wheels, so there's no hope there. It's basically set up radio control, and you just pull out the wires, go into the servos, plug them in through the computer. And it's about $80 minus the radio to radio control, and I'll probably put that as a document too, because some people are asking about it.
It's $80, but unlimited fun.
So, yeah, it can move pretty large loads. I'm going to try to race to some questions that probably going to be asked. It is not set up for a real-time operating system like RT Linux, and it's not a mission-critical hardware software platform, but it's really cheap. Nintendo Wii controllers actually have 3-axis accelerometers, but no gyroscopes on board. the OpenVulture software handles the socket connections, but it doesn't do anything to encrypt that connection. It's pretty much left up to external stuff. So you could tunnel it through SSH for if you don't trust your communications channel. The small electric RC helicopters are pretty much no good for this because they can't really carry the payload. And also as the batteries deplete, their flight characteristics change up pretty good. And it should compile under other operating systems like NetBSD, FreeBSD, OpenBSD. Although the asterisk is NetBSD, to keep it clean, they block some of the functions that we'll probably end up using in Linux to talk to the hardware directly, because not all platforms in their world support it. Like you can't do the hardware writes on a VAX, so they don't support that.
Some of your baud settings and stuff, it's a little bit different. But yeah, I mean, one of the major goals was we kind of wanted to just kind of work right out of the box, so you can build it without very little dependencies. We don't rely on a lot of external libraries when you decide to try to build this thing.
It will compile and run on a laptop computer, and you can set the laptop computer in a vehicle if you didn't even want to bother with the embedded stuff. I think that's pretty much it. Is there time for questions? I'm not sure. Questions? Hey. Oh, haven't thought about that yet, but I see what you're saying. Yeah, the motorized vacuum cleaners.
Yeah, because I mean, we've got a project here at my university that connects, laptops to them.
Oh, nice. Yeah.
This might be an interesting library to.
There should be no reason why it couldn't be used. That's pretty interesting. Yeah, if you had two of them in the air with a radio direction finding setup with, I guess you'd need 4 antennas on it. Or
you know all about that, don't you, Ethan? About finding signals.
But so yeah, it would be useful for that as long as you could pack the radio receiver equipment and the equipment to RDF.
Let's say you're downtown, it's smart enough not to fly itself into a building.
Not yet.
We haven't tested that part yet, but that's why testing's fun. Because the whole SIM card deal, you don't have your SIM. Well,
it'd be pretty much either doing image recognition or some sort of those sensors. So none of that yet. Yeah. But if the flight plan was good enough, then it shouldn't hit anything.
Yeah, the idea is to test it over a field that won't catch on fire. So.
All right. Okay. Thanks. Thanks much.
All right. Thanks.
I was actually thinking about, there's actually a couple other security guys like that. I was kind of, all right, yeah, so.